Welcome to the explainer that's basically going to serve as your ultimate exam masterclass for completely dominating Cambridge IGCSE ICT Chapter 6, which covers ICT applications. I know you've been putting in the hours on your theory, so today we're not just going to sit here and read from a textbook. No way. Instead, we are going to actively reverse engineer the mark schemes. That way, you're going to know exactly what those examiners are looking for when you sit down for paper 1. Let's get into it. Okay, so here's our quick mental map of the 5 core syllabus pillars we're tackling today. We've got number 1, communication, 2, data handling, 3, measurement and control, 4, medicine and expert systems, and 5, manufacturing. We're going to cover the whole shebang.
All right, Section 1, Communication and Digital Media. This is a massive target for the examiner's tricky discuss questions. Let's actually reverse engineer a real 8-mark past paper question from February/March 2022. It asks about Tower School moving from a manual pen and paper system for concert tickets over to an online booking system. Now, to scoop up all 8 of those marks, you absolutely cannot just list a bunch of random thoughts. You need a solid structure. To score full marks on literally any discuss prompt, you've got to explicitly present both sides of the coin using a compare and contrast framework. So for the advantages, examiners love it when you mention that online systems prevent double booking of seats, and, they give parents 24/7 access to book whenever they want without needing to print physical tickets. But, and this is crucial, you have to pivot to the disadvantages to lock in the rest of your marks. You'd point out that the system completely relies on an internet connection, it requires expensive setup and maintenance, and there's always that lingering risk of the website crashing under high traffic. Balance is just absolutely everything here. Moving right along to Section 2, Data Handling and Finance. This is where examiners really want to test your understanding of exactly how money and goods are processed digitally. So, the absolute must-know concept here is EFTPOs. That stands for Electronic Funds Transfer at Point of Sale. It's basically the digital backbone of modern retail. It securely moves money from your bank account to the supermarket the very second you tap your card. Honestly, usually before you've even had time to realize how much you just spent on snacks. Take a look at this 6-mark question from 2021 about contactless payments. We're going to break down the exact sequence of events that the mark scheme is practically begging for. You see, students drop marks here all the time because they just assume certain steps are way too obvious to write down. Don't fall into that trap. You have to write down every single step. To grab all 6 of those marks, you've got to write out the specific step-by-step logic. Step 1, the reader reads the card. Simple enough, right? Step 2, the system checks if the amount is actually under the contactless limit. Step 3, the seller's bank contacts the customer's bank to validate the card and make sure there are sufficient funds. Step 4, if everything looks good, an authorization code is sent back. And finally, Step 5, the exact funds are deducted from the customer's account and transferred over to the school. You can apply a really similar step-by-step logic to automatic point-of-sale stock control. Just always remember to mention the reorder value trigger. It goes like this. A barcode is scanned, the item is found in the database, and the stock count is reduced by 1. But here is the real secret to full marks. You must state that the computer compares the new stock level to a preset reorder value. If it hits that minimum threshold, boom, the system automatically sends a message to reorder more stock. All right, Section 3, Measurement and Control Systems. I'm about to give you the ultimate cheat code for pretty much every question in this section. You need to memorize this 4-step golden loop because it's the exact answer structure they want for questions on car park barriers, glass houses, autonomous vehicles, you name it. Step 1, a sensor, maybe a light or proximity sensor, reads data from the environment. Step 2, that data is converted. Step 3, the microprocessor compares the incoming data against a preset threshold. And Step 4, if the condition is met, the microprocessor sends a signal to an actuator, like a motor or a valve, to take some physical action. And remember, this whole process is continuous. One thing you can never forget is that sensors read analog data, but computers, they only understand digital. So you've got to explicitly name the ADC in your answers. If an exam question asks why a microprocessor can't just read a sensor directly, this is your 1-mark golden ticket answer right here. It needs that analog to digital converter. Let's shift gears to Section 4, Medicine and Expert Systems. This is a super fascinating area where technology actually mimics human intelligence.
For the exam, you have to be able to define 5 specific components of an expert system. It's especially crucial to differentiate the inference engine, which does the actual reasoning, from the rules base. Think of it like this. The user interface is how we talk to the system. The knowledge base is this massive repository of raw facts. The rules base is the set of logical rules. Then, the inference engine is basically the brain that searches the knowledge base using those rules to find a match. And lastly, the explanation system. This is critical because it tells the doctor or engineer why it reached a specific diagnosis, so they know they can trust the result. Beyond expert systems, examiners really want to see that you know how 3D printing is revolutionizing medicine, specifically things like printing highly affordable prosthetics. What's truly a game changer here is the cost factor. Traditional myoelectric limbs, they can cost tens of thousands of dollars. But by using a 3D printer in materials like nylon or plastic, highly functional prosthetic hands can be produced for as little as $100. I mean, that is literally life-changing for patients. They also love to ask about printlets. These are customized 3D printed medicines that release multiple drugs at optimal times for a specific patient. So instead of just a generic one-size-fits-all pill, hospitals can use a patient's exact data to 3D print a single combined dose. It releases different active ingredients precisely when that specific body needs them. It's known as patient-centric medicine, and it's pretty incredible. Finally, we arrive at Section 5, Manufacturing and Autonomous Systems, where automation completely rules the assembly line. When you're discussing computer-controlled robots, always remember they rely on specific sensors to interact with their environment. A robot welding a car door needs a light sensor to know exactly when the car is perfectly in position. It needs a pressure sensor in its gripper so it doesn't just crush delicate parts. And of course, it uses video cameras for quality control inspections. Once again, we see the classic discuss robots versus humans question. Time to pull out our trusty compare and contrast framework for those evaluation marks. The examiners want you to acknowledge that robots provide highly consistent product quality and can work in really hazardous environments, like a nuclear plant or a paint spraying booth. But on the flip side, they have immense initial setup costs, they require highly skilled maintenance programmers, and yeah, they unfortunately lead to human redundancy and manual labor jobs. The undeniable power of a robotic workforce is their ability to operate 24/7 without taking breaks. That right there is a major keyword phrase examiners actively look for. Robots don't take holidays, they don't go on strike, and they never get tired. Literally just writing down 24/7 is almost always a guaranteed mark on these automation questions. Look, if you take away just one single phrase from this entire explainer to use in your exam, make it this one right here. The microprocessor compares the sensor readings with the preset values. Whether the question is about glasshouse temperature control, a robotic bottling plant, or an automatic car park, this is the core logic that the mark scheme demands you understand. As you master all of these systems for your IGCSEs, it kind of leaves us with a fascinating question to ponder about the future of human work in a highly automated world. If machines are going to handle all the repetition and the heavy data processing, your future really lies in creativity, empathy, and complex problem solving. So keep reviewing these frameworks, practice those step-by-step logic loops, and you are absolutely going to crush Paper 1.